Okay, so we're going to get started today talking about misleading graphs and statistics. This is the last lesson from this section of the chapter, so when we come back after the break, you guys will have a review on Tuesday, and then you'll have a quiz on Thursday. So your quiz on the first part of this chapter will be on Thursday, and that will cover box and whisker plots, frequency tables, histograms, bar graphs, line graphs, and then misleading graphs and statistics, okay? So, what does it mean for something to be misleading?
It's not what you thought it was.
Okay, it's not what you thought it was, accidentally or on purpose?
On purpose.
Usually on purpose, right? So if I'm trying to mislead you, that means I'm trying to kind of send you in the wrong direction, right? So misleading graphs and statistics basically means a graph is made in a way that it's trying to make you believe something that maybe isn't true, or maybe not even is false, but it's just like not as big a deal as they're trying to make it out to be. So for example, looking at this graph right here, this graph is what kind of graph is this? It looks a little weird, but it's essentially a what? A bar graph. Which fertilizer is the best?
D.
By a lot?
Yes.
Yes? Is it really that much better though?
Not
Yes.
yes.
So how much, basically what the question is, or what the graph is showing us is the effect of fertilizer A, B, C, or D. And each of those, like how is it measuring the effect of the fertilizer?
In grams.
In grams? So grams is like what? Is grams like how tall something is, how much it weighs? How much it weighs. So we're talking about how much it weighs, right? Is 1 gram a lot? No, 1 gram is really, really tiny, right? 1 gram is not very much at all. So something like a couple pieces of oatmeal, like a couple little flakes of oatmeal, that's a gram, okay? So this graph is basically saying, if I looked at this, I would say I am definitely going to buy fertilizer D because the tomatoes on that plant were 85.2 grams. And that looks like a lot better than fertilizer B. But how much did the tomatoes weigh in fertilizer B?
81.9.
81.9, roughly 82 grams, right? So really, how much better is that?
Like 3.
3 grams, which in terms of a tomato, is that really that much? Again, picture 3 grams as like, you know how big a piece of oatmeal is? Picture like 8 of those. Does that weigh very much? No, not very much. But if I look at this graph, it looks like this one is way better, right? So what did they do to make the graph look like that? What do you mean by made it bigger? Okay, they made it taller, but it's accurate, right? It's accurate, it's just that, is grams the best way to measure that?
No.
No? If you're measuring something like a tomato, you might want to measure it in ounces. So then if you look at this, this would basically be the same amount of ounces of tomato, but because they chose to put it in grams on the graph, all of a sudden, like George said, this one looks huge compared to this one right here. Is it really that much bigger? No, but because of the way the person making the graph chose to make this graph, to use grams, to count by ones, it looks like a huge difference. Who might have made this graph?
Propaganda.
Okay, who though? What? It is kind of like propaganda, but who made it?
Selling it.
People who are selling what?
The fertilizer.
Which one?
So like the people who sell the D fertilizer, they make sure theirs look bigger than
Yeah,
the other
people
ones.
selling fertilizer B probably made this graph, right? Because people selling fertilizer B certainly wouldn't want you to think that the tomato there only was that heavy, right? Also, note how they did the picture. What happens in the picture of the tomato plant in D?
It gets bigger.
It's bigger, and what else is going on in that
And that's
picture?
more tomatoes.
It's got like a ton of tomatoes on it, right? Look at this one right here. How many tomatoes do you see? 3. Do you think it's possible that a tomato that has only 3 compared to this one with like 15 really only is 3 grams of difference in weight?
No.
No, this one would be way heavier if this picture were accurate, right? So is that picture accurate? No, so this is what we call a misleading graph. The graph was created in a way to make you think that fertilizer D is way, way better than fertilizer B. Now, is it better? Technically a little bit, right? It's a little bit better. But if I'm looking at this, I'm thinking, oh, no way I'm going to buy that joke of a fertilizer B, when in fact it's not really that much worse. It's just the way they created the graph makes it look like that, okay? So partly what would help is if they just made it look like straight bars, okay? The other thing that would help is instead of using grams, what should they have done? ounces or pounds or something that was a more accurate representation of how much those tomato plants weigh. Good. Okay. What's going on in this graph? What's going on in this graph? A little bigger. Just tell me about it. You don't have to tell me why it's misleading, but what is this graph? I'm going to call gas prices, right? Gas prices over the course of
That's
some years. How many years?
7, 8.
8 years. The gas price over the course of 8 years. What happened over the course of 8 years?
Gas went up.
Gas went up.
Per
Did
gas.
it go up a lot or a little? Well, where did it start? Started at 108 and now it's 143. So that went up. That's not a hefty amount, right, per gallon. But when did it go up mostly?
During 1979, 1995, or 97, 95.
So it looks like it went up the most between 95 and 97. How much did it go up between 95 and 97?
Like 14 cents.
14 cents. How much did it go up between 99 and 2001?
99.
Almost 20 cents, right? So which one's actually a bigger increase? 1999 to 2001. But what did this graph do that makes it look like it's a way bigger difference here? Because this is a big difference. That's 14 cents, but this is 17 cents. So that should be
Okay, because it's showing because like if you follow from 1.10 gallons to 1.24 gallons, if you're just looking at the graph and not at the numbers at the bottom,
Yeah.
you're going to see the long stretch in between it.
It looks like a huge steep
Yeah, so
line,
you'll
right?
automatically think that that's the bigger.
Yeah, I would absolutely look at this and think, oh my god, that's definitely the biggest jump. If you don't look at the numbers, and isn't the whole point of a graph that you can look at it without having to really think that much about the numbers? It's supposed to visually display it for you, right? So you don't have to think about the numbers. But because of the way they manipulated this graph, it really looks like this area is the biggest interval, when in fact the biggest interval is right here. That looks like a really small jump to me. But when you actually look at the numbers, it's not.
140 to 160, but they become about twos.
Is that why that's?
Yeah, so what happened? What did they actually do on the graph to make it do that?
They went from 118 to 120.
Yeah, look how they're counting here. How are they counting here? First they count by, then they count by twos, and now they count by 20s. Can you do that on a graph? No, because exactly what you guys noticed is what happened, right? It makes it look like this is a huge jump when this in fact is the biggest jump. Because what does this have to be and it's not? What do you have to? It has to be constant. Otherwise your graph is not accurate. Is it technically showing the right data? Yes. But is it allowing someone who's just looking at it quickly to interpret it correctly? No, probably not. All right, and so if I made this graph, I would purposely be trying to get you guys to believe that this was the biggest jump, when in fact this was. George, what were you going to say?
Why gasoline cost?
Because demand, it all has to do with demand for oil. Yeah, because we don't have access to as much oil as we need. So, and then there's countries who have a lot of oil and are withholding it because they know that, I mean, it's all economics. So, somebody is winning, right? It's just, we're not, the consumer's not. But in Houston, we want gas prices to go up because so much of our industry is oil and gas. So you might not as a driver, like I might not because I'm a teacher, I don't really care about the oil and gas industry. But in Houston in general, because so many people here work in oil and gas, we want that like part of the economy to be. So it's a double-edged sword. It's like, oh, I have to pay more, but that means if Houston is doing better, then more people in Houston will buy houses. Maybe I could sell my house for more than I bought it for. Like if overall the economy in Houston is doing better, that's a good thing. So it's like, oh, well, if I have to pay a little more in gas, that's great. But that's why Houston tends to have cheaper gas than most other big, huge cities because we are like the center of oil and gas.
But we're the center and we don't have that much oil and gas.
Well, it's, yeah, there just isn't that much. Like, think of all the demand for it, and the supply is just not that big. That's why we're trying to find alternative sources for fuel. That's why hybrids, and we're trying to see if corn is a possibility. Ethanol comes from corn. That's literally all my knowledge, and it's probably wrong. So, everything it sounded good though, right? I sound confident about that. Okay, alright, so, anyway, yes, Matt. Don't push me further, I really don't know anything. Okay, bye.
So they already found a renewable source, like corn?
It's not actually more economically efficient though. The process for getting from like corn in a field in your car as gas is like super, super expensive. So until they figure out a way to make that more economical, it would still cost way more than gas.
But it has no like oil, it's just all corn. Or, like,
I don't know what it would, like, I don't know, but yeah, it's a derivative of corn.
okay.
Yeah.
Yeah, wasn't there an incentive to like turn algae into like?
I'm sure, yeah, I mean, there's probably still attempts to make that happen, right? Because then you would also be benefiting the oceans, which we need to clean up, right? So, all kinds of stuff. I mean, but then, so you have like the argument of like, coal is a lot cheaper, but it's way worse for our environment to use coal as a like energy resource. So that's why like politicians argue on both sides of that. Like some people say we should definitely use coal. Other people say like look at our environment, things are going horribly awry. We need to do something. And so they looked at ethanol as like a solution for that. But right now it's just not doesn't make sense economically. Okay, so this is misleading because this is an inconsistent axis label. All right. Now, let's answer these together. So take a look at this first one. In graph 1, we've got players and we've got scores. Who scored the most?
What is that, the L?
Lazaro.
Oh, top one.
So Lazaro scored the most, right? Who scored the least?
Kim Lee.
Kim Lee scored the least. Did Lazaro score a lot more than Kim Lee?
No.
Does it look like Lazaro scored a lot more? It looks like Lazaro scored a lot
Because
more.
they did it by ones.
Yeah, because they counted by ones. What might have been a more accurate way to count? Yeah, maybe counting by 5. So it doesn't look like there's such a huge disparity, right? Okay, good. And then on graph number 2, or I'm sorry, with number 1, who might have made that graph? Or who might want to use it?
Lazaro.
Lazaro, because then it makes it look really good, right? Okay, graph 2 is the price over the course of a month. Actually, I don't even think you guys can see this. Let me see if I can make it a little bit bigger. All right, so it's the price of something over the course of several months, and what looks like it's happening there.
It's going down.
Overall, it's going down. Good.
A lot.
Why might? What?
I say it looks like it's going down a lot.
Yeah, it looks like it's going down by a lot. Why might this graph be misleading?
Because they counted by one.
Again, they're counting by ones, so your scale is so small that it looks like it's falling a ton, but really in January, how much did this thing cost?
48.
And in February, or I'm sorry, in December, how much did it cost?
423.
So it only went down by how many dollars? 5. But if I'm looking at this, it's like, whoa, the price of that plummeted. It's not really that accurate because it's counting by 1. So again, you might want to adjust your scale so that it looks more reflective of what's happening. Okay, what's misleading about this circle graph? What's going on in this circle graph? It's a student council election, right? So what's it counting?
It only has 30% out of 100.
Yeah, it only has 30%. It's supposed to have, Angel, you knew that?
Yeah.
It's supposed to have how much?
That's 23.
It's
Yeah, 35.
supposed to have how much though? 100%. So what did they do here?
Only got 35.
Yeah, they took out 70%, which means they either lied about the votes people got, or did they put everybody into this graph who was voted for? No. So it makes it look like what happened. Makes it look like Smith won by a lot, right? When in fact, Smith only had 20% of the votes. So if there's 70 per 65% still out there, could somebody else have won?
Yeah.
Totally, right? But it looks like, I'm just looking at this graph, oh, Smith won. Okay, so pie charts always have to add up to what? 100. If they don't, it's a misleading graph. Okay, sometimes you don't even need a graph. You can just have data and it can be misleading. So this problem says, a researcher surveys people that are leaving a basketball game about what they like to watch on TV. Explain why the following statement is misleading. 80% of people like to watch sports on TV.
Because they're there right now.
Where are they?
Okay.
They're at a game. They're at a sporting event. So if you're at a sporting event, what are the odds that you like to watch sports? Really high. But does that mean that 80% of all people everywhere like to watch sports? No, that's misleading. So if you want to find out what people like to watch on TV, what would be a better way to conduct that survey?
At a grocery store.
Okay, maybe at a grocery store. Why a grocery store?
Like when they're walking in,
Uh-huh.
they're focused on groceries and they're not focused on.
It's not biased.
So why is it not biased though?
Because like, alright, if you're at the game, then you know you automatically like sports. But if you catch someone away from that setting,
Yeah.
then like they can be doing anything. You don't know
Okay.
exactly what they like.
Could it be biased in a different direction if you're at a grocery store?
Yes.
Why?
I love watching health
Maybe, yeah, you might like the Food Network if you're at the grocery store, right? You like watching cooking shows or something like that. Okay, and this is predominantly the people who are at grocery stores, depending on the time of day you go, is really different, right? Like when I go grocery shopping, I'm there with literally only people with families. Like I shop at 7 a.m. on a Saturday and everybody around me either has kids or like had left their kids at home, but everybody there is like a family person, right? But if you go at like 7 o'clock, 8 o'clock on a Friday night, who's at a grocery store?
The single people.
All the single people, right? But no, it's true. Like I used to shop on Friday nights and it was like, okay, well they buy a lot different stuff, right? And grocery stores use that data, but then the single people might like to watch totally different stuff. So when you do a survey, for it to be accurate, it needs to truly be what?
More dominant.
As
Non-biased.
random as possible.
Yeah.
You need it to be as totally random as possible. So you need to like select, if we came into this school on like a day when everybody was here. So let's say there's like some day in May where everybody's here for the last day. And then to make it truly random, you would have to just say like, okay, I'm gonna take a list of all the students and pick the 25th person on the list and then the 50th and then the 75th or whatever and survey those people, then that would be a more accurate way to do that. But again, still biased because you guys are all what?
Students.
High schoolers, and you guys probably lean towards like different types of TV shows than I watch, right? Okay, Brennan?
And I think that's kind of like the what's the TV show, the Family Feud.
Oh yeah.
Like every time like people they'll say some good answers, but then it'll be like a totally different thing.
Yeah, and
It's
that's true because they just ask the audience members, right?
Yeah. Like they surveyed 100 people. What people are they actually
They're
surveying?
people who like you and who are like all. I mean, you would think your audience is pretty similar demographically. So yeah, you're right. That's a good point. I've never thought of that. So that's not a random survey at all, right? Good. Okay. All right. What's wrong with this pie chart? It's only 80%. So what about this? Like, why might Dante show this graph to somebody? What does Dante want to show in this graph?
He's responsible.
Diego? He's responsible? Yeah, he only spends what does he spend his money on? Lunch, which you have to buy, right? And then school supplies, yeah, right, Dante. And then also a little bit on movies, right? But where's the other 20%? If you had to guess where Dante's other 20% was spent, where would you guess? Probably somewhere he didn't want to tell them.
Yeah, like
right?
how's 40% more than 50? Like more than the graph.
Yeah, that's true. So this is 30%, this is 10%. So how much is that?
40.
And isn't this also 40? So shouldn't at the very least those two things be equal? And are they? No. So this graph is like completely off in many different ways, okay? All right, and last but not least, number 3. Joe surveyed at an Italian restaurant about people's favorite foods. He said 75% of people prefer Italian foods. What's wrong with that? He's at an Italian restaurant, okay? Well, if you're asking people what your favorite food is, and you go to an Italian restaurant, what are people going to say? Italian food. There's nothing wrong with Italian food. I love Italian food. I'm curious about the 25% of people who are there that don't like Italian food, but that's besides the point. Okay, so if you go to an Italian restaurant, you can't ask somebody what's your favorite type of food. That's a biased survey. All right, so go ahead and do these 4 on your exit ticket, and then that's it.